Hi, AP Physics students. Only one problem for T5.2, and it's number 37. Notice it's got a star. The star doesn't mean that it's necessarily harder than a lot of the other problems. It just takes a couple of different kinds of steps. And so we'll start with the conservation of momentum. The person's running horizontally, and they jump onto a sled. So if you want to know what the velocity is later on, this is conservation of momentum. The way you attack conservation momentum is you put an equal sign in the middle. And beforehand, you have the momentum of the running person. And so you could call that M1, V1. Afterwards, you'll have an M1 prime, V1 prime. Remember, the prime stands for afterwards. Well, both things have changed. Here is relatively simple algebra. You have to realize that everything can be substituted and we'll just solve for the V1 prime. So you have to understand that M1 prime stands for the mass of the object afterwards, and V1 prime is the mass of the velocity of the object afterwards. And so that won't be so hard to solve for the V1 prime. The challenge comes in part B. In part B, after you jumped onto this, then friction takes over. So there are a couple of ways to solve this, and either one would be fine. The thing to realize is the only force stopping this, so the only force in the problem, in fact, we would call it the net force, is friction. And so since the only thing stopping you is friction, there are two ways to approach it that are equally good. One is to realize that the kinetic energy change is equal to the work done by friction. And so the change in the kinetic energy is just the 1/2 mv squared, because you lose it all, because you're going to stop. And the work done by friction is the force of the kinetic friction times the distance traveled. So there's one way to solve that and to get the friction formula. The other one is to realize that there's no reason you can't use the net force equals ma to solve this. Again, in this circumstance, we know the mass. The acceleration can be found by kinematics, and then once you find the net force, you can use the force of friction formula to find the coefficient of friction. Hopefully this gives you a little bit of a start. Have a nice time.